Hello students, today our discussion is about dimensional analysis, which is the most important part from the units and measurements for the mains and for the NEET level also. So dimensional analysis, just in generally when you speak about dimensional formula or dimensional analysis, before this one we should know about this. What are the types of physical quantities? Fundamental physical quantities, derived physical quantities. For the fundamental physical quantities are how many there? 7 fundamental physical quantities are there. Derived physical quantities are what? Many are there. So many other than those. Okay. So these derived physical quantities can be classified, means what they, so if you want to represent the derived physical quantities in terms of fundamental physical quantities, we need a process. That process is called what? Dimensional analysis. Dimensional analysis is what? It's a process of, it's a process of conversion, of, okay, process of conversion of derived physical quantities, derived physical quantities into fundamental physical quantities, fundamental physical quantities is called what? Dimensional analysis. Okay. For this dimensional analysis, so dimensional formula. What is dimensional formula? Dimensional formula is, so just the powers of fundamental physical quantities. How many? So first one in this process of conversion of derived physical quantities into fundamental physical quantities. Okay. So secondary physical quantities into primary physical quantities, like dimensional formula. So dimensional formula is what? It's a m to the power of a, l to the power of b, t to the power of c. Sir, you are writing only 3, so remaining also we can write, total 7 also we can write on this. The dimensional formula is what? It's a the powers of fundamental physical quantities. Powers of fundamental physical quantities. Okay. So powers of fundamental physical quantities is called what you say? It's a dimensional formula. Here we can say it's a m, l, t, so on. These 7. So these are called what? Fundamental physical quantities. These are fundamental physical quantities. And A, B and C are called constants. Just constants, like. Okay. Like for example, if I say the example is what? Force F dimensional formula is equals to m l t to the power of minus 2. M power 1, L power 1, T power minus 2. Mass, length, time. So these are the dimensional formulae. These are what? Fundamental physical quantities. And 1, 1 minus 2 are the what? Constants. So this is the force is expressed in terms of this. Okay. So let me know on this, how can I write the dimensional formula of given any physical quantities. Okay. So how to write dimensional formula. Okay. So dimensional formula of any physical quantity. Yes. How to write the dimensional formula? For this, very first one I am talking about. First one is about length. Okay. Length is what? It's a L. Length is L. It is measured in what? Meter. Okay. So dimensional formula, and next one, second is about mass. Okay. So next one is about time. Yes, time. So generally mass is measured in, it's what measured in kg. Yes, this is measured in kg. This is measured in meter. This time is what? T is measured in what? Time, seconds. Okay. So what is the dimensional formula of this? This dimensional formula is length means what? L, like L to the power of 1. So also we can write about m to the power of 0, L t power 0. Okay. So it's what mass is what? It's a m, capital M. And next one R. So we can write m L power 0, t power 0. And time is what? It's a second. Second is what? It's a measured in, like it's a t. So this you can write m 0 L 0. It's a t, like. So dimensional formula of length is what? L. L. Remaining terms are what? Power 0. Dimensional formula of mass is what? M. Dimensional formula of time is what? It's a T. Okay. So if you write about for the fourth one, what is the area? Okay. Area. Area means what? A. A is equals to what you say? Length into breadth. Its units are what? Meter square. Meter square means dimension formula is, we can write, meter means it's a length. So length square, or m to the power of 0, L square, t power 0. Okay. Next one, for the fifth one is about, this is area. Next, volume. Volume means V is equals to length into breadth into height, means what? Meter cube. It's a cubic meter. So that's what? It's L cube. Your wish, anyone you can write, or L cube, otherwise M0, L cube, T0. Okay. It's a volume. And next one, for the sixth one, is velocity. Okay. I'm writing about velocity. Velocity is what? V. So speed. Speed also it's what? Just its directions only, but magnitudes I'm talking on this. So its velocity is equals to, we can write, displacement by what? Time. So displacement is what? It's a d, and time is what? It's a t. So dimension formula of displacement is what? It's a length. By time is what? It's a t. We can write on this L t power minus 1. L t power minus 1. So like seventh one, if you write about acceleration, okay. So that acceleration is what? A. A means what? It's a change in velocity by time. Change in velocity means velocity only. What is the dimension formula of velocity? By dimension formula of time. Dimension formula of velocity is what? L t to the power of minus 1 by what? T. We can write as L t power minus 2. Okay. This is for acceleration. So if you write about the force, okay. So for force is what? F. F is equals to what you write? Ma. I want to write the dimension formula of force. Dimension formula of force is equals to dimension formula of mass, dimension formula of acceleration. It's a F is equals to, m is what? Capital M. Acceleration is what? Lt power minus 2. This will become as what you say? Mlt to the power of minus 2 is the force. So you can write any dimension formula like another one. So just if I write on this, next I'm taking on this here. So for the ninth one I'm taking as, for example, work done. Okay. Work done. Work done is what? W. W of dimension formula is equals to, so dimension formula of F into dimension formula of S. Okay. Product of force and displacement. So dimension formula of W is equals to dimension formula of F, dimension formula of S. So this F is what? MLT power minus 2. Dimension formula of S is what? It's a L. We can write on this ML square T minus 2. So this is the dimension formula of work done. Do you know work done and energy, will have the same dimensional formula. Okay, so let me know about this is what it's a dimensional formula of energy. Energy dimensional formula. Okay, energy means what? For your better understanding, we can take it about either kinetic energy or potential energy. Kinetic energy, potential energy, same dimension formula and the same units. So it's because of the classification of the energy. So dimension formula of energy is what? I want to know about kinetic energy. Kinetic energy dimension formula Ke. Ke is equals to what? Half mv square. Dimensional formula. This is what? Half is a constant. Don't write it. This is what? No dimensions. And it's what? Dimension formula of mass. Dimension formula of velocity square. It's what? M. Okay. Velocity is what? Lt power minus 1 square. This will be ml square t minus 2, which is equal to dimensional formula of work done. Okay. So, like these are just in mechanics part, so many dimensional formula we can write on this. Not only this, in the heat and next one in resistance, potential, charge, all we can calculate. So just I'm giving some more on this. And next one is, for example, I want to know about pressure, dimension formula of pressure. Pressure is what? It's a P. Okay, this is P. Dimension formula of pressure is equals to, we should know the formula first thing. Pressure P is equals to what? Force per area. Dimension formula of force by dimension formula of area. So dimension formula of pressure is equals to, what is the dimension formula of force? M L T minus 2 by A means what? L square would become as, what do you say? M L to the power of minus 1 T to the power of minus 2. ML minus 1 T minus 2 is the dimension formula of pressure. Okay. So next I want to write about, and so dimension formula of coefficient of, otherwise stress. First one is about stress. Okay, stress is equals to what? Force per area, you know. So dimension formula of stress is equals to, so force per area. Force per area means what? Same, like you need to get it as this. So what is this force? M L T to the power of minus 2 for the force, and area is what? L square will become as what? This will move up and it become as L power minus 2. Minus 2 plus 1 is minus 1. It's what? ML minus 1 T minus 2 is the dimensional formula of stress. Okay, same like it's a pressure. Next one, just I'm talking about 13th. For example, velocity gradient. Velocity gradient. Okay, velocity gradient. Velocity gradient means what? Any physical quantity is divided by position, a distance. So velocity gradient means what? Velocity by distance. Okay, it's a distance. Or we can also write delta V by delta X. Delta V by delta X. Okay, so this delta V means what? Velocity. Velocity is what you say. So I can write about LT power minus 1. And delta X is what? L. Would become as what? T power minus 2. This is what? Velocity gradient. Okay. So for the coefficient of viscosity, coefficient of viscosity. Okay. Coefficient of viscosity. Coefficient of viscosity is what? Eta. Eta is equals to what you say? Stress by velocity gradient. Okay, stress by velocity gradient. What is the stress dimension formula? M L minus 1 T minus 2. Velocity gradient is what? T minus 1. What's your answer? ML minus 1 T minus 1 is the dimension formula. T minus 1 would become as T plus 1 when transposing from here to here. Minus 2 plus 1 is what? Minus 1. ML minus 1 T minus 1 is the dimensional formula of coefficient of viscosity. Okay, so dimensional formula, for example, charge, if you want to know. Okay, so I want to know about the dimensional formula of charge. So dimensional formula of charge is what, from where do we get this? Our current I is equals to what is the formula? Q by T. Yes, Q is equals to what you say? I into T. Dimension formula of Q is equals to dimension formula of I and a dimension formula of what? It's a T. So would become as what? Dimension formula of I is I only, because one of fundamental physical quantities. There are 7 fundamental physical quantities, and dimension formula means what you are expressing in terms of fundamental physical quantities. Okay, the powers of fundamental physical quantities. You may write as I also, or A, ampere. A also we can write. So I, next one is what it's a T. So this is IT, that's it. Dimension formula of charge is equals to, so it's what? Dimension formula of Q, this is equals to what? IT. Okay. Next one for the 16th, like many you can write it on this. If I want to know about electric potential or electric potential difference, okay, you can go through this. This is what? Electric potential. Electric potential. Okay, difference. Electric potential difference. Now potential difference is what? V. V is equals to what? W by Q. W stands for work done. Q stands for charge. W is measured, means what? The dimension formula you know, charge dimension formula also we know it. Okay. So this is what? Dimension formula of potential is equals to dimension formula of W by dimension formula of charge. But dimension formula of W means what? Work done. That's what? M L square T minus 2. By charge is what? IT. I can write on this is what? M L square. Okay. L square T minus 3 I minus 1 is okay. So M, and it's a L square T minus 3 and minus 1. Like we can write, this is about 16th. Okay. And from the gravitation, if you speak about from the gravitation, my gravitation is what? 17, like if I say this. So here gravitation F is equals to G into M1 M2 by R square. I am asking about what is the dimension formula of G. Okay, what is the dimension formula of G? But G is equals to what you write? G is equals to F into R square by M1 M2. Dimension formula of G is equals to dimension formula of F, dimension formula of R square, dimension formula of M1, again dimension formula of M2. Okay. So like this is F is what? M L T minus 2 is the force, and distance is what? L square, and mass is what? Capital M. Next one is M. So we can write on this M L. So M cancel, right? One M is cancelled. This M become as what? M to the power of minus 1. Next one L square. What is this? L cube T to the power of minus 2. Okay. So check on this. What is the dimension formula of G? G is equals to F R square by M1 M2. F is dimension formula is what? MLT minus 2. And R distance. Distance means what? It's a L square. And mass M1 and M2. M and M. M is what? So one M is cancelled. M to the power of minus 1. M minus 1. L cube T minus 2. The constant which has the negative dimension formula. Negative dimension formula. What is this? This is what? It's a universal gravitational constant. Okay. Careful on this. So this is what? Universal gravitational constant. Like many we can write the dimensional formulae. Okay. And what are the uses of this dimensional formulae? Okay. So dimensional formulae, many physical quantities, and we can use to derive the, to know about the dimension formula. Okay. To write the dimension formula of any physical quantity, we should know the formula, and next one we should know the relation between the quantities, like. Okay. So after this, what are the applications? Yes, applications of dimensional analysis, applications of dimensional analysis or dimensional formula. What are the applications? What are the uses? Okay, first one is about to check the correctness of equation or to convert one system of units into another system, and next one to know the relation between physical quantities. First one is about to to convert okay, one system of units into another system, and next one is about to check, so to check the correctness of equation, of equation. So to check the correctness of equation, and next one to know, okay, to know the relation between physical quantities. So physical quantities. So these are the three methods to find and to know about, to use the dimensional formula in for example, energy E is equals to mc square. If you write about E is equals to mc square, sir, instead of E equal to mc square, I want to write E equal to mc cube. So mc cube means what? Is it dimensionally equal or not, left side and right side? So we don't know. So we should go to this method. Means some particular formula is given, particular equation is given, dimensionally it should be correct. Okay. So to discuss about all these three things, we should discuss about this principle of homogeneity. Okay. So this is what principle of homogeneity. Okay. So homogeneity. What is the principle of homogeneity? Principle of homogeneity means what? For example, can you add velocity to the acceleration? Can you subtract velocity from the acceleration? Means here velocity can be added to some velocity, acceleration can be added to some other acceleration, force is added to some force. Okay, but here this principle of homogeneity can explain about this the physical quantities of same dimensional formula. Okay, so can be added, can be subtracted, can be equated. Okay, so is the condition. What is the principle of homogeneity? Just I'm now discussing this.